So, you've heard developers throwing around the word Docker, and you're kind of wondering what the big deal is. Well, you're in exactly the right place. Think of this as your personal study guide, a quick crash course to get you from Docker curious to Docker competent in just the next few minutes. Let's get right into it.
Here's the game plan. We're going to start with the one single problem that Docker was born to solve. Then we'll build up your vocabulary with 3 concepts you absolutely have to know. After that, it's all hands-on. We'll do a real workflow, see how to manage an app once it's live, and then finish up with a pro-level skill, how to keep things neat and tidy.
Ah, yes, these 6 little words. They are probably the most frustrating phrase in all of software development. You know the drill. A developer codes something, it works like a charm on their laptop, but the second they send it to someone else or push it to a server, bam, nothing works. And why? Because the two computers are just different. This is the exact headache that containerization was invented to cure, for good. Containerization basically puts your software in a standardized box. And the best analogy for this is a real-world shipping container. Before those existed, loading a ship was pure chaos. But once you have a standard box, it doesn't matter what's inside, you know it'll fit on any ship, any train, any truck. A Docker container is that same idea, but for code. It bundles up your application and everything it needs to run so it behaves the exact same way everywhere. Okay, so how does this magic actually work? Well, it all boils down to 3 fundamental building blocks. Seriously, once you get the relationship between an image, a container, and a volume, you've pretty much cracked the code of the entire platform. Let's take them one by one. First up is the image. The easiest way to think about an image is to picture a blueprint for a house. It's a static, unchangeable, read-only template. It is all the instructions written down. Start with this foundation, which is like the operating system. Install these pipes and wires, like the software dependencies, and put this code inside. Since it's immutable, you can't change it, which means every house built from this blueprint will be identical. Okay, so if the image is the blueprint, the container is the actual house you build from it. It's the live, running version. But here's the catch. The container has what's called a writable layer. You can go inside, you can paint the walls, you can move furniture around, but all those changes are temporary. The moment you destroy that container, poof, it's all gone, and you're back to the original blueprint. And that temporary nature would be a disaster for things like a database, right? You can't just lose all your user data. So how do you save the important stuff? That's where volumes come in. Just think of a volume as an external hard drive. You plug it into your container house. The container can be created, destroyed, rebuilt, but all your precious data stays safe and sound on that external drive, ready to be plugged into the next one. So let's put it all together. This is the key takeaway. The image is your unchangeable blueprint. The container is the temporary, live instance you spin up from that blueprint. And the volume, that's your permanent storage that outlives the container. Honestly, this table is your ultimate cheat sheet. If you get this, you get Docker. Okay, that's enough theory. Let's get our hands dirty and see how this all works in the real world. We are going to walk through the exact steps you'd take to get your very first application up and running inside a container. It's really just a simple 5-step recipe. First, we find the blueprint we need. Then we download it to our machine. We use it to run a live instance. Then we have to open a door so we can actually talk to it from the outside world. And finally, if we need to save anything, we attach our storage. Simple as that. Step 1 is finding an image. So let's say we want a web server. If you're a command line person, you can just type Docker search to find the official Nginx image. Or you can pop open the Docker desktop app and browse visually. The key thing here, either way, is to look for Docker official or verified publisher. That's how you know you're getting the good stuff from a trusted source. All right, next up, we need to actually connect to our web server. By default, containers are totally isolated. Think of them as a sealed room. The -p flag for publish is how we open a door. We're telling Docker, hey, connect port 8080 on my computer to port 80 inside the container. In the desktop app, it's literally just filling in a box. And what if we were running something important, like a MySQL database? Well, we absolutely have to save that data. The V flag for volume is our best friend here. We're creating a named storage space called MyDBData.
and basically connecting it to the exact folder inside the container where MySQL keeps all its files. This is what guarantees our data will still be there tomorrow.
Awesome. Our container is officially running. So, now what? The next big skill is just knowing how to manage it. How do you check if it's healthy? How do you see what it's doing? Or even, how do you sneak inside and poke around? When you're working with Docker day to day, it really just boils down to these 4 things. You got to be able to see what's running, check the logs for any messages or errors, keep an eye on how much CPU and memory it's eating up, and sometimes you just need to get a command line inside to figure something out. So, to see what's currently active, Docker PS is your go-to command in the terminal. It gives you a super quick and clean list of everything that's running. On the other hand, the containers view in Docker Desktop is like a full-blown mission control dashboard with live status updates and little buttons to stop, start, or delete things.
Need to know what your app is actually doing? Docker logs is the command for that. And here's a little pro tip for you. That -F flag means follow. It gives you a live, scrolling stream of the logs as they happen, which is absolutely critical when you're trying to debug something. In the app, it's just a simple click on the Logs tab. And sometimes you just have to get inside the container to see what's really going on. Docker Exec lets you do exactly that. The IT part is the magic sauce here. It stands for Interactive Terminal, and it gives you a command line that lets you run commands like you're right there inside the container. All right, we've covered how to run and manage containers. The very last skill, and this is what separates the beginners from the pros, is knowing how to clean up after yourself. Docker can fill up your hard drive surprisingly fast, so having good, tidy habits is a must. And this is the question that scares a lot of people when they're starting out. You know you need to free up some space, but you're also terrified that you're going to accidentally nuke that one critical volume that has all of your database info. So what's the safe way to do this? The secret is all about understanding dependencies. Think about it. You can't throw away the blueprint, the image, if you still have a house, a container built from it. It doesn't even matter if the container is stopped. So the proper order is always the same. Get rid of the containers first. Then you're free to remove the images they were made from. Volumes are a whole separate thing. Docker gives you these amazing prune commands to automate cleanup, but you have to respect their power. Let's look at them by safety level. Docker Container Prune is pretty safe. It just cleans up stopped containers. But as you move down the list, they get way more aggressive. And that last one, Prune Volumes, that's the big red button. It will delete any volume that isn't currently attached to a running container. So you have to be 100% sure before you ever run that one. And really, that's the whole point of all of this. Once you mastered these ideas, that whole "it works on my machine" problem just vanishes. You now have this incredible tool for building software that's consistent, reliable, and can run anywhere. So the only question left is, what awesome problem are you going to solve next?